Hello, and thanks for joining us today. On today's webinar, we're going to talk about how to solve 5 common discrete water sampling challenges. And we're going to focus on environmental data. But to get things started, I want to introduce our main presenter. That's Dave Gilby. He has been working in the water resources industry since 1993. He's our water quality analyst here at Aquatic Informatics, and he's been working in the public sector managing NPDES stormwater permits, as well as TMDL programs. Dave works on our solutions team, and he has a lot of experience working with customers on their specific applications and really understands their day-to-day challenges and needs, which is going to make him a great presenter and expert on this subject. And I'll introduce myself. My name's Tim Finnegan. I'm actually new to Aquatic Informatics, but my background is on the instrumentation or the hardware side of the industry. Back then, I used to joke that no one liked to buy sensors and instruments. Ultimately, I think a lot of the folks in the line are after the information that these instruments can produce. And really new software tools allow us to go from data to information a lot more quickly. And we hope to showcase that in today's webinar. On the next slide, I just wanted to quickly walk through the logistics and the agenda. We did a lot of market research in preparation for this webinar. We actually called customers, did a lot of interviews, a little bit of market research. And we know there's many challenges you're facing when you're trying to process your environmental data. But the 5 themes that really came out as we talked to folks over and over was the first around decentralized data, the second around managing many different types of data. The third issue was filtering, finding, and sorting data. The fourth issue was correlating, validating, and processing that data. And the fifth was sharing that information and visualizing it. And the way the format's going to work is I'm generally going to briefly introduce these challenges, and I'm going to pass it over to Dave to walk through some of the software and address how these tools can address these challenges. At any point in the webinar, please feel free to type questions that you'd like to see answered. We'll do our best to save some time at the end to address these questions. And if we don't get to them at the end, we'll certainly follow up within a day or two with a personalized response. So with that, I want to pass it over to Dave to kind of kick things off.
Great, Tim. Thanks for that great summary about today's webinar. I'm really excited to show the audience today how things you brought up at the beginning of the webinar are addressed in AQUARIUS samples. I put together some examples of how the data management challenges you addressed at the beginning can be significantly simplified and even in some cases overcome. But before we get started, I do want to introduce the audience to AQUARIUS samples at a very high level. This is AQUARIUS samples, and it's a web-based platform. And what we're going to show you today is some information related to field trips and field visits, how that data that you're collecting on the different sites can be logged into a sample and a specimen bottle, how all those field measurements you're taking can be spun up into one area, how all the lab reports from those samples and specimens and those taxonomic measurements can be brought back into what we call the observation. We'll spend quite a bit of time going through each one of these, but before we do, I do want to introduce our example organization today, and that example organization is the Department of Environment. And the Department of Environment is really an aggregation of customers' examples that we've put together for today's webinar. They're real solutions. We've anonymized the data and the location, but really it's an aggregation of real challenges. So our example today, our organization, the Department of Environment, is a government agency with headquarters in Portland, Oregon. They have satellite offices all over the Northwest, and they had some really specific needs when they first started looking for a data management solution. They needed to share data in near real time, and what I'm talking about is actually discrete data, not real-time data from a continuous sensor. They needed a single source of truth. They were struggling with managing all their data in spreadsheets, and it really became a barrier to them being able to communicate with one another and find out what that true data value was. They have a very diverse set of staff, environmental scientists, engineers, biologists, managing data, really across this region. And they have really a core set of projects and work types that they're involved with, specifically projects around monitoring compliance with mining, restoration projects on rivers and lakes, as well as they're involved in some source water protection for drinking water sources, definitely a hot issue here in the west coast of the United States, and they do quite a few watershed evaluations. They've started using Aquarius samples about a year ago, and now that we've been introduced, Tim, to our example organization today, I'm going to pass it back to you so we can talk about that first topic of decentralized data.
Thanks for that quick summary, Dave. I just wanted to reiterate for the audience, we are going to refer to DOE, or Department of Environment, as a fictional example. These are based on real-world examples, but we wanted to keep the data and the users anonymous. So the first challenge that came out of our market research was definitely that challenge around decentralized data. And here we have an example office based in Portland where they were managing a lot of environmental data in a spreadsheet. But additionally, they had sensor files. These were binary files or CSV files that came off the sensors in the field. They also had another office where they had a different version that they tried to sync through an Excel spreadsheet, and they were also capturing biological information inside of a database that they had built. They were working with a cooperator or a third-party organization, and in this case, this group was outside of the firewall, and they also downloaded the spreadsheet to do some data entry and manage some of the data files from the sensors. The challenge that our customers were running into was actually trying to sync all this information up. And as we tried to get a 360-degree view of the environment, things like data being orphaned in a folder or on a device, environmental files being scattered all about the network, different locations depending on which user is using it. Issues came up that data was actually behind a firewall and some people who needed to get to it couldn't. Simple things like even just managing the different date and timestamps on those files was a challenge because the data was coming in from different offices. So a lot of frustration came out from our interviews with people dealing with all of this data spread across the organization. And really the rate at which new data is being introduced is increasing and it becomes more difficult to manage. I also wanted to talk on the next slide how some similar parallels can be drawn in other industries. So in the financial industry and the business systems industry, there's been a big trend towards centralizing your data. But one I wanted to bring up specifically was what's happening in the national health record databases. Increasingly, hospitals, pharmacists, primary care providers are sharing patient information into a centralized database. And this is improving patient outcomes by giving a 360-degree view of the patient. The similar parallel can be drawn to what's happening in the environmental market. A lot of different colleagues and cooperators are collecting environmental data, but increasingly this can be orphaned in different databases and different solutions. So I'll pass it back to Dave to kind of show how a software tool can help manage and deal with some of this decentralized data.
Great, thanks, Tim. So when our organization that we're going to be talking about today moved, when they first came to us, they were interested in moving away from spreadsheets to store the data that they had. And basically they wanted to have all their data in one format. They wanted to improve their data integrity, data quality, defensibility, as well as have some data level validation. You can notice from this graphic, dealing with just 4 different offices and everybody dealing with a spreadsheet to house their data, small changes can cause havoc with the data that is contained in those spreadsheets. But one of the really most tangible benefits that came from DOE's transition to Aquarius samples was the ability to have the data accessible to everyone, regardless of their location. So Aquarius samples provided DOE role-based access to the various employees at the different offices, as well as a change history in that data. And they're not guessing anymore, Tim, which spreadsheets are the most current or the last time that the data was updated. Now the staff at DOE just logs into Aquarius samples and they all have the data they need right at hand. DOE, just by going to samples, has also eliminated some of these common errors like transcription errors that are related to sample data management by using Aquarius samples. Again, they focused their efforts on this single source of truth, and they basically have no clashing versions of spreadsheets anymore. Aquarius samples is allowing their users to focus on the data itself and not those time-sucking activities and administrative tasks like aggregating data or modifying or correcting those spreadsheets, Tim. So let's dig into Aquarius samples a little bit, and we'll take a look at how that centralized data works. So here's Aquarius samples, and right away you can see we've got some data in our window here. I'm just going to bring up some example data here just to show everybody. I'm just going to bring up a site and I'll just bring up one parameter here. We'll just bring up some nitrate data. And when we bring up that data, you'll notice that we have quite a bit of data in our system already. One of the first things that DOE noticed was that Aquarius samples was handling their dates consistently and efficiently. Now, this might seem like an obvious function to most of the people in the audience today, but you'd be surprised how much time was spent on DOE's side with working with spreadsheets that had all kinds of problems with date formats, and even the automatic spreadsheet functions that were automatically applied every time a spreadsheet was saved. They also noticed that these text fields that were in the system were handled quite efficiently in other complex data formats like the observed properties that we have here. So the actual parameter values here were handled much more efficiently. You know, talking about the complexity of the data, Tim, they can just click on one data point and they can continue to drill into that metadata that's associated with each site. They can, in each observation, excuse me, so they can drill right into the lab data. They can even go as far as drilling into the specimen bottle and find out what else was taken out of that bottle for analysis. So, Tim, I was thinking while we were putting together this webinar about an article that I read recently, and it had to do with the finance sector and how spreadsheets that are used in the finance sector, there was a survey that was done by a group that basically said that the respondents from this survey said that about 35% of them knew that there was errors in the spreadsheet they were using to make decisions. That was a bit of a shocker to me, but not really, because I think we deal with clients all the time that have the same kind of revelations. You know, furthermore, the same article mentioned that each one of the people using those spreadsheets spent on average, about 12 hours a month just consolidating and correcting those spreadsheets. So if you bring that out to a year's worth of time, you have about 144 hours a year just spent on administering that spreadsheet, and that ultimately results in quite a bit of time lost. So with that, Tim, I think I'll pass it back up to you. I think our next topic is different data types, if I'm not mistaken.
Yeah, thanks for that introduction, Dave. Certainly our number 2 challenge that came out, and we heard this over and over, was managing a lot of different data types. And just some quick examples, you may be dealing with probe readings or sensor readings, which are your field results. You may be processing laboratory information, and this is not only numerical data, but maybe the method or the limits of detection or important QA/QC data that's a part of that laboratory report. Perhaps you have a colleague who's also capturing biological information like algae, fish, species, or taxonomy. There's also categorical results, so things that are non-numerical, like the presence or absence of certain features or weather observations. We heard from manual profiles that were being done. This is kind of 2D data that varies both with time and depth. Sedimentation samples, the list goes on and on. But I wanted to bring up a specific example, and I spoke to a gentleman named Joe, and he actually was a reservoir manager in the southeast United States. And on his reservoir, they would go out, especially in the summer months, and sample algae. They would process that data back at an on-site laboratory. They'd also take turbidity readings with a handheld meter. They would also go out on the lake and collect data about what was happening with Secchi depth, and they would lower a profile and record that along with some weather observations. A state agency was actually doing fish counts on the reservoir, And there was real-time data coming back from the drinking water intake from an in-situ fluorometer that was being presented on the SCADA system. So managing all these different data sets, including a vertical profiler, is a real challenge for an organization because Joe spoke about this being trapped in a lot of different information. He had a SCADA system where he could view operation data about his plant, but all of these different sample sets and data types were really trapped in LIMS systems and spreadsheets and databases. So really, I'd like to kind of demo now in software how Joe's example could be realized in a new software solution.
You bet, Tim. So let's take a look at AQUARIUS samples again. So, you know, Joe's example is not an uncommon one for sure, and the challenges, Tim, you brought up related to those data types at the beginning of that slide really are, you know, pretty commonplace. So our example today, DOE was really no different in their struggles with you know, managing those different data types. More specifically, they had data that could either be stored as categorical or numeric, and typically those two data types of data were stored in different spreadsheets or different spreadsheets and on their network. So when DOE started using AQUARIUS samples, they no longer needed to store that numeric and categorical data separately. So let's take a look at what those different data types look like. So in this case, let's look at a grouping of data here. And that grouping of data will allow us to take a look at those different categorical and data types. So I'm going to go into a field trip here that's basically a summary of multiple locations sampled over a specific time period. And let's drill into one field visit, if you will. So one visit that was done at this location. And you'll notice that those different data types, like the samples that were collected, here we can further drill into this really complex data set and look at the 3 different bottles that were collected along with the requested analytes for the laboratory. We can identify different laboratories for each bottle if we need to and put that together. We can look at the field results that Joe may want to put in his data management system. I'm sure Joe's collecting field data from those inflows and outflows of that reservoir. Our example at DOE is no different. They're recording some field measurements here. Certainly they can do something like a field survey, and if they're doing those fish counts you've mentioned, Tim, we can certainly look at those fish counts in terms of looking at that combined data. So let's say in Joe's reservoir they found a great white shark. And that great white shark has some color, it has a length, a weight, a maturity level, you know, what was it, male or female, so on and so forth. So we can continue to add things like you know, flora and fauna into these field surveys. We could add trees and all different kinds of habitat measurements if we wanted to, all contextualized in the same area. And really, with being able to add all these different data types together, you have automatically contextualized that data, and that contextualized data provides a lot of value than sitting in disparate areas for sure. Any of Joe's vertical profiles can also be spun up in the same area. Tim, what's really nice is, yes, the data's here, but we also have the attachments. So these could be pictures that we're taking on site. Again, they're all attached to this date and time with this field visit. So any of the, again, any documents, scans of write in the rain notebooks, all can be put in there, as well as there's a change history down here at the bottom to define when anything had changed on the page related to any of the data points. So, you know, really a more holistic way of looking at those different data types in context of one another. With that, Tim, I think I'll pass it back to you.
Yeah, thanks. We wanted to take a break now and actually get some input from the audience. So we were going to kick off a webinar poll to see which of these different data types you may be managing. So if you can click through on your screen and give us a little bit of feedback, we'd be interested to see, in addition to the field readings and laboratory results that you may be processing, what are the other kind of data types you're managing? And we'll just take a few more seconds, getting a lot of different results in here. Awesome, yeah, we have a huge audience that's participating here. All right, I'm gonna close the poll and share the results. And we can see that certainly a lot of folks are doing vegetation, fish, kind of field survey and biological results. And this really resonates with what we heard from a lot of our customers is coupling the water chemistry data along with some of this biological information presents a lot of challenges, and usually that's dealt with separately. So thanks for sharing that, and we're going to check in one more time at the end to kind of see which of these challenges most resonate with you. But before we go there, let's talk about our third challenge, and that is finding and sorting data. And so I did an interview with an environmental department manager, and he was at a state agency, and he kind of lamented that he was about to lose a 20-year veteran employee. And this was the go-to person at the organization that everyone would rely on to kind of write the scripts to query the database. He'd be the one to kind of patch the database over the years. And they were, kind of wondering and scratching their heads how they were going to deal with this challenge. And more generally, this kind of legacy expertise was repeated from a lot of folks we spoke to. A lady I spoke to, she had to train 2 different database administrators in a single year. And she was frustrated that this was kind of a single point of failure that really the whole organization had to kind of rely on this person to get data out. It was a bit of a bottleneck as you went through. And so really looking at how software solutions can help deal with kind of finding, filtering this data so that the individual data and analysts can actually interpret some of this data would be a powerful feature that I think AQUARIUS samples can help show us.
Great, Tim. So let's take a look at AQUARIUS samples. And one of the things I want to show is especially that contextualizing data and finding that contextualizing data. So let's take a look at a field visit where, Tim, you had mentioned in the last section about Secchi depth. So one of the things that's unique about Secchi depth are there's some observations that you need to make along with your Secchi disk readings to really qualify that reading. So things like position of the sun, maybe wave height, all that can be recorded in the field results section along, again, with your field surveys, your samples, and your vertical profiles, and any potential attachments that you might have in that system. Furthermore, certainly finding data is a key thing, and it reminds me, Tim, of that webinar that you and I attended a while back where I believe the statistic that was used was that there was a group that tried to use some metals data, and about 60% of that metals data couldn't be used because the sample fraction wasn't recorded with that data. Do you remember that webinar, Tim?
Yeah, absolutely. And I think a lot of folks on the line can appreciate all the effort that goes into collecting and maintaining that instrumentation only to ultimately not be able to have it usable. I think it was something like, 60% of the metals concentration was ultimately not able to be processed.
For sure. So I wanted to, I was thinking this morning that that's actually a really great example for, finding data. And how would you find out what the sample fraction is? There's a couple of different ways in AQUARIUS samples. One is just being able to hover over the value in AQUARIUS samples. Here we're looking at some copper observed properties. So our copper results have that additional that property of a sample fraction. So I know that as I hover over each one of these, I'm going to get the sample fraction. But furthermore, I can actually filter out just those total values if I want to, and I can create a list of just my total sample fraction. So if I was looking at something like all different kinds of metals, maybe copper, lead, and zinc, I could bring up all my total or dissolved data really easily. Now, in our example today, we've certainly talked about the day-to-day administration of data for Department of Environment, and we've outlined that quite a bit. But keep in mind that DOE has realized, a much easier way to query and the ability to quickly find data. There's no SQL queries, there's no Visual Basic to write in the background. Any user, once you're up and running, can start using AQUARIUS samples and use the associated filters we have here to find your data. And one of the common projects that DOE does is they set up new networks, new monitoring networks for their newer existing clients. And some of the common tasks that they undertake are, just looking at the data and, trying to find data that's associated with this potential product or project, and, things like, hey, are any of my values out of compliance? So let's do a quick sort here. And just like any web page that you would typically go and interact with, we can filter these, or excuse me, sort them on value. So I'm going to sort these on value, and you'll notice that if I hover over this notification on the side here, that we're automatically informed that these two data points in 2012 and 2014 exceeded a human health criteria. So this might be in a human health criteria associated with drinking water, and automatically that data is flagged and the user is notified of that exceedance. So that's one way to certainly find that data. Tim, I know that some of our users at DOE also want to know where where that data is located. So they're able to actually use the map feature to find out where that copper was sampled at, as well as the last value and date that was sampled at that location. So really taking that data that you put into a system and contextualizing it to convert that data into information. So with that, Tim,
real quick, Dave, we had a question about the individual parameters that came in, and they were wondering, can they be modified, or are those kind of set in stone?
Completely. So yeah, so each one of these observed properties here can be added by the Aquarius samples administrator. So anybody at your organization can set up this list. There's a list that comes with Aquarius samples, but certainly you can create those observed properties on your own, as well as analysis methods and so forth. There's a whole section in settings that you can get to those observed properties for sure.
Thanks, Dave. Well, let's jump to our fourth data challenge, and this is one I'm intimately familiar with, and that is the challenge around correlating and validating real-time and discrete data. And so one example I ran into all the time was around chlorophyll A, and users would take an in situ fluorometer and put it in the water, but to calibrate that signal, you actually need to use laboratory extractive analysis. And what happens is a lot of users were just using the default values in that fluorometer because it was a lot of work to pull the binary files off, convert them to a CSV, put them into a spreadsheet, run data analysis, and then marry up that data once a month or a couple times a year with the extractive analysis. And as a result, a lot of people just didn't do that work because it was so intimidating and cumbersome. So there was a big disconnect between the real-time data and the laboratory data. Another example that comes up all the time and is very topical is around nutrient loading. Nitrate and phosphate analyzers are incredibly expensive and difficult to measure in real time, but there is certainly a desire to want to see nutrient loading occurring in real time. So by marrying publicly available discharge data with your nutrient analysis that may be done at the lab, people want to actually calculate and estimate loading in real time around nutrients. Someone we specifically spoke to also talked about a TMDL project where they had done a great job of working up a spreadsheet that modeled a lot of these calculations between real-time data and discrete data. But the challenge was, as soon as they went on to the next project, it was very difficult to extract all those computations and those workups that had been done in macros. They were kind of buried and hidden in the sheet. So it was very difficult to transfer that knowledge on to the next project owner. And we also got a couple questions in from the audience about doing kind of real-time loading calculations. So if you could show us any kind of real-world examples, Dave, that might apply to correlating and validating this data.
You bet. So let's talk about that first example, Tim, that you had mentioned, which is validating a data set. So this is an example of a chlorophyll sensor, and what the audience is seeing on this graphic is the red triangles are actually lab results of chlorophyll analysis, that extractive analysis that you'd spoke of earlier. So being able to use that extractive analysis to validate your time series signals is a very common task that we have with our customer base. And now that Aquarius Samples allows you to basically mine and utilize all that rich metadata, you can use that that data in the system, but the grab samples, the chlorophyll grab samples, all the metadata that surrounds that is now discoverable. So you can use that data again to validate your signal. So basically what you're seeing here is basically a multi-point drift correction from Aquarius time series, and using those validation points to again validate the time series signal. So if we take a look at what that looks like once I implement that correction, you'll notice that we still have the raw time series data. We have our grab samples that we've used to validate our signal, and then our blue signal that's on the screen here today is actually our validated and corrected time series signal. Now again, I just want to repeat that data that's associated with each one of those grab samples, like the MDLs, MRLs, what methods were used, what laboratory it went to, whether it was Tim and I that sampled that data point or somebody else, that's all discoverable in Aquarius samples for each one of those data points. So it really makes this a very powerful tool when you integrate that time series and discrete data. Now, Tim, a lot of times people don't even want to do a validation. They just want to do an empirical observation. This is very common. So something like taking a discharge signal and looking at some E. coli data, you know, this can provide quite a bit of insight just by plotting this data one on top of the other. And again, once you set up a system like Aquarius Samples, as you add data to that Aquarius Sample system, it's ported over to Aquarius Time Series. So as you go into your Time Series system, it's already there. The systems work very well together. And you know, in this example, the visualization roughly shows that at higher flows, we've got almost a whole order of magnitude lower E. coli concentrations, and obviously the inverse is true at lower flows. You know, just by a quick look at this, an observer might indicate that, or might conclude that there's a constant source of E. coli to this water body, regardless of discharge. Now, anybody that's in the audience today that deals with stormwater BMPs or BMP placements, certainly this is something that's probably on your radar about trying to determine where your pollutant load reductions can happen. And by just looking at these empirical observations can certainly help you in the beginning of those projects, as well as evaluating the effectiveness of those BMPs long term. The last thing that I want to show, Tim, is you'd mentioned loads, and there's a lot of questions about calculating pollutant loads. So I've spun up some total phosphorus data in the system as basically some time steps, 15 minutes time steps about pounds per day of total phosphorus that you can calculate. So basically taking that data from Aquarius samples, bringing it over into time series, and using a relationship to develop that pollutant loading. And certainly that's something that's very easy to do in the Aquarius system, and very useful, especially again with the BMP maintenance, BMP placement, so on and so forth. Tim, I believe in the webinar resources there's actually a link to a webinar that we did last year, I believe it was last year, with a group that actually was using Aquarius Time Series to calculate pollutant loads. So that's a resource that I think everybody can access with the webinar resources.
Yeah, absolutely. Well, once we get the webinar recording uploaded, we're going to send out an email that'll have a link to that if you want to reference it on your own. And with that, let's go into our fifth and final challenge. And that's the challenge around sharing and visualizing information. So we spoke to a lot of customers who talked about the challenges associated with visualizing information. So one of the common scenarios was someone would do a lot of work to visualize the data only to kind of see an outlier or something that needed more investigation. But as we talked about the challenge with decentralized data, it was very difficult to go back through the whole process, run new queries to try and drill a little bit deeper into the information. Another challenge was really organizations moving away from their data silos. So as we saw in the survey results, sometimes the water chemistry group is sitting in a different place than the biology group, and sharing those results across the organization is increasingly more difficult, but more important than ever. Another thing that came up around sharing information was sometimes public grant monies were made available, and there was a responsibility to make that data available to the public, but that was a significant burden in terms of the organization around supporting that and getting that data out into the world. And increasingly, we're living in an open data kind of revolution, and people want to leverage third-party tools like Power BI, R, or Tableau to create visual reports that can be used to share that information. and to even leverage things like APIs so that third-party tools can access that database without having to log in. So could you walk us through some of how Aquarius Samples addresses these visualizations and sharing challenges?
You bet, Tim. So let's do just that. So let's take a look at, again, let's go back to our observations, and let's start there for data sharing. And you'll notice when I go into this screen, we're going to come up with the same filters we were working with before. And so we've got some copper data, some reviewed data here. I'm just going to clear out those filters, and let's use just a different example here. We'll use the same site, and I'm just typing in a few letters of the site that site ID that I know, and we'll use something like nitrate. And when I bring up this data, you'll notice that the data that we have, we can certainly view it in a list, but what's really helpful is to be able to look at this data in terms of a chart. So here's a chart of the data that we have in the system. You'll notice right off the bat that we have an outlier here that might not be so obvious when you're sharing this data as a list. So being able to provide that graphic of what this data looks like is pretty important. Now notice as I'm hovering over it, we can get some more information about that data set. Furthermore, just like the observation screen, I can click on a single data point and get more metadata about it and continue to drill in and put this data point in context. What's really nice about a system like this is I can also create something like a box plot to visualize my data. So this is done on the fly. It's looking at all the nitrate data that we have in the system. I can get things like the interquartile range automatically, the median value, and just like the graphic before, I can hover over the data points and get more metadata about those just by clicking on them. Now, what's nice about this is, when you're setting up networks like our DOE example or something else, we could also spin up this data as a specific date range. So let's just take a look at a year's worth of data, and there's that. Let's take a look at even maybe 2 years of data. And it's pretty easy to switch back and forth between these different visualizations. And it makes it nice because if you've ever tried to do this in a spreadsheet or even some of the off-the-shelf products, trying to create these box plots can be pretty problematic. At any point in the Aquarius Samples system, Tim, our example organization, they're constantly using things like the export function here. So they can actually export their data, the data that you see on the screen here, as a list. So they can export that to a CSV. So any of the data that's associated with this box plot can be exported. Furthermore, if any of you people in the audience today, if any of you have any needs to export data to the US EPA's Water Quality Exchange, if you're in the States, we can export that data to an XML file and you can upload that on the WQX web, really simplifying your data delivery to the US EPA if you've got some requirements. Tim, I think some of our organizations that we spoke to said that they have requirements based on project funding to report to the EPA. So furthermore, these are some ways that you can just share data literally in Aquarius Samples. Now, Tim had mentioned APIs before. There's a whole host of APIs that sit behind Aquarius Samples that allow you to connect your data in this system to things like R, Power BI, Tableau. There's actually an Excel plugin that just came out recently. So if you've got Excel 2013 or earlier, it's called Power Query. And it's just a plugin, it's a free plugin from Microsoft that allows you to take advantage of these things like these web services. Aquarius Samples is basically a web service that you can connect up Tableau and so forth to get those dashboards and scalable reports and so forth and all connect them together. That's something that our example organization does quite frequently using our APIs. Now, one of the things that our example organization has done is they've taken their data management even a step further. They are starting to use something called Aquarius Web Portal. And the nitrate data that we looked at earlier, here's an example of what it might look like at a group of, grouping it together in a group of sites at different locations. And you can notice that we've contextualized the data insofar as we have some values on our legend here related to normal to extreme values of nitrate. We can zoom in and out on this on this graphic. We can look at a list of data and look at the data class. We can sort just like we do in the other screens. Quite useful to share this data, and this doesn't have to be something that is just kept internally. You could use this externally to share with an organization, like if maybe you're working with another group or a consulting group or a regulatory agency where you want to communicate your day-to-day operational activity. You can see how this kind of ad hoc reporting and visualization could really be useful in that kind of context. With Web Portal, Tim, you can even take it one step further insofar as I can sign in as a named user into the system, and I can do some really simple things like create a dashboard just for a project, if you will. So here's an example project that we have up on our Aquarius Web Portal site. You'll notice we have some widgets here related to River Stage. We've got a graphic here where we can actually zoom in on a data set so we can actually interact with our data. And the window that I'm creating here, I can actually slide this data back and forth. And if I have real-time data coming in, both time series and discrete data, that data can be piped into one of these widgets, and we can see that data as far as where we are right now, right this second. You'll also notice on this dashboard that we have a view into our Hobart, Australia office. This is a view from their office, but you can imagine how this type of platform like Web Portal, you could have a webcam at a site specifically for monitoring an operation or conditions at the site. You could pipe a webcam in here. And doing other things like having a little video if you want to have this internal to your organization, maybe an internal website related to more resources, maybe some Twitter feeds, things like that. So with that, Tim, I will pass it back over to you, and we can talk about the next poll, I believe.
Yeah, we'd like to take this chance to kind of get one more input from our audience here. So I have up on the screen a webinar poll where we'd like to see which of these data challenges your organization is struggling with the most. And so, yeah, if you could take a moment to kind of click on the screen. At the same time, feel free to type any questions in. We actually have a great attendance. We have lots of questions to get through here, and we'll get to that in just a couple minutes here. All right, I'm going to go ahead and just give you guys a few more seconds. Great. All right, well, we can see certainly a lot of folks kind of are struggling with that correlation and analysis of the data, and that's something that rang true with a lot of our interviews where folks were having to deal with legacy expertise that was necessary to get this information out. I think the hope we were trying to show was by putting this in a system that anyone can access, a lot more people can start to use these tools and start to get to meaningful conclusions. But before we get to your questions, I wanted to go ahead and pass it back to Dave to just summarize what we went through.
Great, thanks, Tim. Yeah, so in closing today, hopefully what we spoke of resonates with you and the data management challenges you have. And the challenges we spoke of don't have to be barriers. Tim had mentioned this is just a small listing of the data management challenges that we came across. Surely these and others don't have to be barriers that prohibit you from successful data management. And ultimately systems like AQUARIUS samples are going to help you maintain and improve the quality of your data, which is what we're all hoping for. And that data that you've worked so hard to collect and maintain, you want to be able to preserve that as a valuable asset. That data is a valuable asset to your organization, and you should always strive for that goal. Your organization can benefit from a modern and scalable system like AQUARIUS samples. Our example organization, DOE, surely has. And regardless of whether you're a small office of 2 or 3 engineers or scientists, or a large organization, that's got offices throughout the world or throughout a region with lots of employees, making these small changes, like using the right tools for data management, can make large differences in the bottom line. And I think that's what we're all looking for. Remember that organizations with successful data management are using these modern systems to generate the highest quality data that's accurate, defensible, accessible, modern, secure, and safe. I think that was definitely something that came out of our research, Tim, that certainly those organizations that were using modern systems had those qualities about them. Tim, I'd just like to take this time just to say thanks to everybody for taking the time to listen and tune in today, and I'm assuming we're probably ready for some questions now.
Yeah, thanks, Dave. Great job. The first question is from Jessica. She was asking, how do you actually get data into the centralized system?
Great question. So let's take a look at AQUARIUS samples here, and we're just going to go and we're going to import some of that data. So I'm going to go to the import section here, and typically your data is going to come to you in some type of EDD format. And what we'll do is I will bring up some data here. I've got an example here we can use. And the first example I'll bring in, this could be from an FTP server, an email you got from your data provider, and we're just going to drag that report in. Now I've made an example out of this report in that I've seeded it with some errors just to show you the data level validation that as you're bringing data into the system. So first and foremost, we should know that anybody that's working with this type of data, they may have the issue of dealing with different time zones. So AQUARIUS Samples is smart enough to know that those default time zones, it knows what your browser is using. So in this case, I'm using Google Chrome, and AQUARIUS Samples just knows, hey, this is the time zone you're currently in. I can do things like bring in a new lab report or update a lab report, and let's just bring a new one in and just to show Jessica what that looks like. I'm going to bring it in from this laboratory. You can have a whole host of laboratories in your system with all the organizational and contact information that you need. Typically, those PDFs that are sent come with a case narrative or a QC summary. They may come digitally, but typically those come on a PDF. And then once we click our next button, basically what we get is a preview of the data that we're going to bring into the system. Now, this is a pretty easy example to show you that we've got some errors in the file, and it's not uncommon that some of the errors that you have in a file from a laboratory might get ported into your system and then create all kinds of havoc for data cleanup later on. But what AQUARIUS Samples done is it helps with this initial data level validation to prevent that data from even hitting your system. So in this case, we've got an observed property that doesn't exist, and in this case, the alkalinity is spelled wrong. The result for this total carbon result looks like it says it has to be numeric. So my guess is there's probably an error in the file that has both numbers and letters in there, and this observed property requires that the results be numeric. The same with something like an analysis method. So in this case, the lab returned an analysis method that you don't have logged in your system. So this would be a way for you to say, hey, that's not the method that I asked for. Can we double check that? Maybe they've just renamed their method. But this is a way for you to catch those errors on import. Now let's take a look at what that looks like once in our example here. I'm just going to show that we've gone out, and just for the sake of time, I have another file that shows what those corrections look like as we bring them in. So again, we're going to bring in the lab report. It's going to automatically look at the name of the lab report, the time zone, the date and time that it was received. I'm here on West Coast time, so it's about 11:45. We have a choice of what laboratory it comes from. Again, I could put a QC and case narrative if I wanted to. But then we can bring that data in. In this case, the lab report already exists. So that would tell us that that data already has hit the system and allows us to not bring in duplicate data. So again, Tim, there are lots of different ways that you can bring different data types and different data sheets in the system, but certainly this is a way to prevent those duplicates and from errant data coming into the system.
And along those lines, yeah, Jeff was asking about how you can deal with people making changes in the system. So how is that tracked? And this was kind of along the lines of version control. If you have different people making edits, how is that managed?
Okay, so edits and so forth are taken care of in AQUARIUS Samples through a change history. So if I drill into one of our sample results here, I'll show you what that looks like. So let's just go to the specimen bottle that nitrate sample came from. And we'll see that we've got some nitrate that was brought into the system. And let's actually look at the sample itself. So we can look at the sample bottle, the sample results that are attached to the bottle, and you'll notice on almost all the pages in samples, when there's data on the page, there's this thing called change history. So let's take a look, Tim. If I do something like, let's just edit this page really quickly, and I edit, let's say that my field notes said that this is actually 1.5 feet deep and not 1.5, I can go back in and edit it, and I'll save it. And notice now at the bottom we've got a change history by when the sample was created, what time, by who. This was created by me, and when it was last updated. So notice that we've got today's date and time and me associated with the system. So that's attached to every data point within the system. There's this holistic change history. So you can have those those things like what happened to the sample. Something's changed with it. And you can track that through a log that's in the system.
Awesome. Thanks, Dave. We have a few questions in here about the web portal. So I guess, generally speaking, can that be made to display data for the public without needing a login?
You bet. So the view that we have here is a login that is it's what we call a named login. The view that I showed you before, if I sign out of the system, you'll notice that we'll go back to a previous view, and we'll probably come up with some data that I've got set up for, I believe it's in Canada, and yeah, so here's a live view, and this would be basically what we call an anonymous view. So Aquarius Web Portal can be set up for internal or external users for sure. So if you want to use your web portal to just serve data up to internal organizations or divisions of your organization, you can do that. You can also share it with the public. There's a way that you can just have what we call an anonymous user, and the organization decides how much or how little they want to show. You may decide that these tooltips that show up on Aquarius Web Portal, do you want to show these to your anonymous users? And you can even set it up as far as you can have those anonymous users being able to download some of the data associated with these sites. So for sure, Tim, wide gamut of possibilities with a web portal. For sure.
Great. And so we're also getting some questions when you showed the box plot. That really resonated. Could you just walk us through that screen again in terms of how you got information on there and any changes you might be able to make to that display?
You bet. So the box plot is served up based on your filters here. So we could do a couple different things. We can, let's just take our date and time stamp off here, and let's bring up our copper results again. And we'll leave the nitrate results up as well. And what I'm going to do is I'm going to actually bring this up as a chart, and you'll see that we have both data sets now for this site in the same chart. So we've got different symbols that show one for copper, one for nitrate. But we can also do that with the box plots. So again, with the box plot data, we'll just get rid of, let's just get rid of that one copper result there, and you'll see that that copper data now is just based on what filters we have up here. So again, if we said what's the status, let's just look at the review data. That filter will filter down that data in this visualization. Pretty straightforward. And again, you can do that with the data classification. If you're doing something like pH is a great example. If you have pH data that's collected in the field and pH data that's generated by a laboratory, you can filter your graphic and your list based on those data classifications. So many different ways to filter your data and bring it all together. And again, the date range, doing things like this year's worth of data. We don't have any data for this year, but let's look at a custom range of data, maybe 2014 through 2017. And we can bring that data up really quickly. So again, it's just a matter of putting those filters together and completely configurable by the user insofar as you can use these filters to serve that up. And again, don't forget, Tim, that you can export this data too. So if this is a data set that you want to share with somebody, I could share this nitrate data very easily just by exporting this to a CSV file.
Great, thanks, Dave. Certainly, we have a lot of questions here, so I really appreciate the audience being so engaged. We only have time for a couple more, so I do want to kind of assure you that if you've typed a specific question that we haven't answered, we'll give us about 1 to 2 days, and we'll get you a personal email with a response to that question. One question that came in was, if you're in the field, can you directly enter data into the system?
You bet. So a couple different ways you can do that. So the AQUARIUS samples allows you to enter data directly into the system. This system is, basically what I'm doing is I'm displaying AQUARIUS samples in a web browser. So all you need to do to get started and to use AQUARIUS samples is a web browser, a user account, and a Wi-Fi connection. So if you're lucky enough to have a Wi-Fi connection through your phone or just a 4G signal, you can certainly use this platform on a mobile device. The back end of this system will allow you to display on virtually any piece of hardware. So regardless of whether it's an iPhone, an iPad, a tablet, a laptop, as long as you have that connection, you're good. We have quite a few users that are using their own custom field forms, and they basically save those custom field forms with, let's say, some field measurements and sample information. They collect all that in the field when they don't have a Wi-Fi connection, and they can bring that into through the import process we spoke of before. I will say, Tim, that I know our dev team's working on a mobile solution, so for the audience, stay tuned on that mobile solution that's going to be hitting the market very soon.
Well, great. That pretty much does it for the time we have allocated for the webinar. And like I said, we'll kind of get you an email out to those of you who had very specific questions that we weren't able to get to. So thanks very much for attending. And it'll take us about 12 hours to get the video uploaded. Once we do, we'll kind of pass out a follow-up email that'll have links to some of the reference materials in the recording, should you want to share or reference this earlier. So thanks very much for your time and participation.